One, two, three.
What's up, team? Today we're going to find the zeros of a quadratic. This is super similar to what we did last time when we solved quadratics by graphing. In fact, I've left the same 3 steps up here because we're essentially going to use them. We're just using a little bit different terminology. Sometimes you'll hear solve, sometimes you'll hear find the zeros. I'm going to explain what the difference is and really how they're the same thing. So we learned last time, when you're solving a quadratic by graphing, you gather all 3 terms on one side and then you graph the thing. So if we're given this question, here's our example. Find the zeros of this quadratic function. We're given f of x equals x squared plus x minus 6. Well, step 1 here was to gather all 3 terms on one side. Well, done. We got it. And before, we recall, when we did that yesterday on that last video, we had 0 equals stuff, and then we replaced that with the f of x, and then we graph blah, blah, blah. So we kind of skipped a few steps here. This was handed to us this way. That's great. So when it says find the zeros, and notice how it's plural there too, we are trying to figure out basically where does f of x equal 0. So we're going to head over to our graph, we're going to type this in, and we're just going to look like where does f of x equal 0? Like where does that happen? What are the x values? Again, this is just like yesterday. So what we're looking for is where does this graph cross the x-axis? Okay, so let's open up our Dsmoos here. And I'm going to type in y equals, and then we have an x squared, we have a plus x, and is it minus 6. There we go. Here's our parabola, vertex down here at negative 0.5, negative 6.25, and it's got a couple zeros. I'm noticing there's one here, and there's one there. It's just where the graph crosses the x-axis. So we have a 0 at negative 3, we have a 0 at positive 2. Okay, that's really all we need to graph for. We just need those 2 points. Now, let's go back to our algebra stuff here, and let's verify. So we had x equals negative 3, x equals 2. We believe these are the solutions, but we are mathematical-minded people. We need proof. We need to convince ourselves that this is true. So we are trying to figure out where does f of x equal 0. So to check this, we're going to say 0, and we're going to question mark. We're going to see if it's true. And we're going to substitute negative 3 in for x on this first one. So we have negative 3 squared plus a negative 3 minus 6. And we're going to see if this is true. Does 0 equal, this looks like 9 to me. Negative 3 minus 6, that looks like 9. So does 0 equal 0 here? Yeah, absolutely it does. So x does indeed equal negative 3. Let's check the second one out. I'll change colors here. We're going to type in 2 here. So does 0 equal 2 squared plus 2 minus 6? 0 equals, 2 squared is 4 plus 2 minus 6. 4 plus 2 is indeed 6. 6 minus 6 is 0. We found another winner. So when you're asked to solve a quadratic by graphing, or when you're asked to find the zeros of a quadratic, you're really looking for the same thing. Those 2 terms are synonymous. The reason we use the word zeros sometimes is because those are the points when f of x equals 0. And again, just like last time, more often than not, when you're asked to find the zeros, there are going to be 2 solutions. That's just by nature of the shape of a parabola. Again, sometimes it goes up, sometimes it goes down. But generally, if you're asked to find the zeros, your parabola is going to touch the x-axis twice, and you need to find both of them. Rarely, it's going to touch just once. That's when the vertex is on the x-axis, either opening up or down, doesn't matter. And once in a while, actually fairly often I suppose, it kind of depends on the examples, you are going to find parabolas or quadratics with no solutions. That means they never cross the x-axis. An example of that is a parabola opens upward where the vertex is above the x-axis, or when it opens downward, but the vertex is below the x-axis. Okay, let's dive into some practice problems. You got this.